Hello everybody, this is Zareian from Power Electrical Developing Advanced Research Group. In this training video, I'm going to talk about the simulation of the paper entitled Real-Time and Online Dynamic Reconfiguration Against Cyber Attacks to Enhance Security and Cost Efficiency in Smart Power Microgrids using Deep Learning. This paper is one of the perfect and one of the best papers which is published in the field of dynamic energy management and dynamic configuration because it considers all of technical and economical aspects of the smart power microgrid during the operating of the power microgrid. Actually, this paper suggests us a comprehensive solution to control the generation of HDGs and a state of dynamic reconfiguration to reduce the affection and disturbance that is caused by the cyber physical attacks into the system. For example, if you look at the conceptual model which is presented in figure number 1, you can see the LSTM neural network which is used for real-time decision in power system. This LSTM use the dynamic reconfiguration for control the system. Also, as you can see in this figure, this is the main upstream neural network with different microgrids separated in different parts of the different parts of distribution networks. And you can see the LSTM when the LSTM neural network uses the variables of the magnitude and angle of the voltage as an input, and it considers the different state of switching in power system for different type 1, type 2 and type 3 to control the generation and control the dynamic switching in power microgrids to reduce the affection of cyber attacks in systems such as line outage and generator outage in power microgrids. Also, if you can look at the table 2, you can see this paper considers different factors such as energy management, uncertainty, losses, and different technical and economical and reliability index in power system, which is neglected in different previous modern research. Before starting to talk about the simulation of this paper, like the previous training video, go to the mathematical problem formulation in this paper. As you can see, this is the mathematical problem formulation for solar and wind generation units. Also, as you can see here, you can see the modeling of battery energy storage. And also here, this is the modeling of uncertainty of load and renewable energy resources. Also, you can see different type of dynamic reconfiguration in power system where the dynamic switch, there are 3 types of dynamic switch in power microgrids. For example, type number 1, it is related to the switch between each microgrid and main upstream network, and another type of switching is related to the switch between all of microgrids, each microgrid between also another type of the switching is related to the coupled transmission line in power microgrids and power distribution main upstream network. Also, you can see load ability limit criteria, which is considered in this paper, and expected energy not served criteria as a reliability index. And also you can see different multi-objective optimization problem that is considered in this paper. Also, LSTM neural network uses different variable as an input, and it considers different type of switching as the output. This LSTM neural network can provide us the real-time application in control and management of the power microgrids. And also at the next station, you can see the topology of 118 bus for as a benchmark of this simulation, which is considered as a case study in this paper. And as you can see, there are 3 microgrids in this system, which is placed in the different bus. For example, the microgrid number 1 is placed in bus 26, and another microgrid is located in bus number 79, and another in bus 117. And as you can see, different state of the irradiance and temperature and window speed in different figures as the input data. And in this table you can see different method which is run for this model, and this paper compare the efficiency of this paper in compare with the different model which is presented here. And this is another simulation result which is provided you here. So if you want to run the simulation of this paper, I open the simulation of this paper. Just it should be noted, this simulation is as a demo and pilot model for this simulation, and a perfect simulation which will be presented in the next upcoming training video. So if you want to open this simulation, just you can double click on this folder and just copy this link address and paste it in your link address of your Matlab simulation software, and by press the key enter here you can call all of the simulation file here. If you want to open the simulation file, just enough to double click in main, and by open this file you can see the simulation. This simulation you can run this simulation in your computer by 2 states. In state number 1 you can call all of the real simulation, and if you uncomment this 2 line of Matlab code and comment this Matlab code here, you can call all of the real simulation file for last method and purpose method. If you run this main file, you can see these 2 files. This 2 Matlab file is open and call, and the simulation starts. However, you can run the Matlab simulation file for getting the result using the saved result in the last simulation result which is provided you here. Also, if you want to see the Matlab file for this simulation, you can see the matrix of the input data, for example bus data and load data for IEEE 118 bus, and line data bus matrix here. Also you can see the cost matrix of the generation. We will talk about all of the simulation and all of the Matlab program code in detail in upcoming next training video, so don't worry about it. And you can see the information data about each microgrid, microgrid number 1, microgrid number 2, and microgrid number 3, and the switching between the main upstream network and each microgrid you can see here. Also you can see the distribution generation for each microgrid. Also, you can see dynamic reconfiguration information here for dynamic coupled switch, and also you can see here the switching between each microgrid and main upstream distribution network. Also, there is the matrix of load factor, irradiance for PV number 1, irradiance for PV number 2, temperature and wind speed. And as you can see, this paper run for different time interval of 20 hours, 24 hours of a day. And you can see, for example, if a line outage is happened to system, for dynamic switching of power system, what happened to the energy management and how we can control the generation of each DG, and what is the best state for dynamic switch if a cyber physical attack such as line outage is happen at each time interval into the power microgrids and main distribution power system. And you can see the result of the power microgrid. For example, 11 Newton is used for power flow in power system in the simulation. We will talk about all of details in the simulation in next upcoming training video. Also, you can see the PSO algorithm to optimization of the objective function. For example, there are two objective functions here, objective function number 1, objective function number 2, where the objective function number 1 is used for purpose method and objective function number 2 is used for the simulation of last previous methods. So if you want to run the simulation and get the result here, you can run the this file by press this key, and the simulation is start and you can get the result. However, this process is very time consuming, and I want to use the last simulation result which is saved here. So I comment these two Matlab code here and uncomment this Matlab code to show you the result which is saved in the last running of the simulation here. By press the run key here, you can see the simulation result related to this paper, which is optimized by the Matlab simulation, and you can see the result of the dynamic switching here. If you so you can see the dynamic switching for type number 1 during of the 20 hours of a day, and dynamic switching number 2, dynamic switching number 3, and dynamic switching number 3 here. And also you can see the simulation result for different objective function for proposed method and previous method. And we will many thanks for your attention and stay tuned. Bye for now.